Okay, so here are some supplemental problems from section 7.7 from the homework, from the worksheet. Um, so we're finding simple interest here, which the simple interest formula is interest equals principal times rate times time. A lot of people call it I equals PERT. I did R times R, didn't I? Principal times rate times time. So in this case, our principal amount is the initial amount. That's what principal stands for. So principal is what you start off with. Your rate is your percent, but it's as a decimal. So yes, it's 5.5%, but that's going to end up being 0.055. And then your time is 36 months. Now, the time is going to be weird because time is in terms of years. It's not in terms of months or hours, or it's in terms of years. So I have to convert 36 months to years. Well, there are 12 months in a year. So that equals 3 years. Okay, so in this problem then, I know my time is 3 years. My interest is 0.055 because again I convert that to a decimal, and my initial amount, my principal, is 1900. So interest equals 1900 times 0.055 times 3. And this is definitely a calculator problem. This section is definitely a calculator section. So 1900 times 0.055 times 3 equals, oops, that's just 0.5, didn't it? Do that again. 1900 times 0.055 times 3. $313.50. That's how much interest we would add on. Okay, so another problem then, that was number 4. Number 8 in the worksheet. Now I picked 8 because it's still simple interest. It's still I equals PRT, so I equals PRT, or again, principal is 875. Rate this time is 0.023%. Okay. But now this time with time, we have a weird thing that happens because 3 months is not a full year. So I can't just do 3 again. Last time I couldn't do 36. So when I divide 3 by 12, because it's 3 months out of 12, I get 1/4, which actually works out nicely because it's 0.02, I'm sorry, not 0.025, but 0.25. Okay. So it's 0.25 years. It's a quarter of a year. So now we just, again, throw it into the formula. Interest equals 875 times 0.023 times 0.25. Now, if this hadn't worked out nicely, if this would have been like 0.273476, we would just put whatever the fraction was in for that. But instead, it did work out nicely. We can leave it in terms of a decimal. Okay, so let's see what we get when we do this time. So 875 times 0.023 times 0.25. And we get 5.03, which really means we get about $5.03. Not a lot, but again, that should make sense. It's a pretty low interest rate, just 2%, and it's not even for a full year. So we're not going to get a lot out of it. Okay, next problem is compound interest. And this one's going to take us a little time because I have to do this 5 times. Okay, so here's how compound interest works. What happens is you're going to take, again, interest equals principal times rate times time. But we're going to change things up just a little bit. Because how compound interest works is that whatever you had for the previous year, it still keeps working into it. So, for instance, if I just found 1 year's interest, that would be, for year 1, it would be 13,900 times 0.0, or sorry, not 0.0, times 0.125 times 1 for 1 year. I'm not doing it for 5 yet. This is the first year. Now what that ends up giving me then is 13.9. Nope, sorry about that. That doesn't work the way I thought it would. 13,900 times 0.125 times 1. That's 1 year. So in 1 year you would add on $1,737.50. Now, that's not how much, that's the much interest you have, but the amount of money you have is actually 13,900 plus this. So 13,000 plus 1737.5, which is a total of 15,637.50. Now that's after 1 year. And then what happens is, like, that's the amount of money, let's say, we have on our bank account. Well, when I go to do interest for the next year, I'm going to take interest of this amount of money. And to be honest, the simple interest we do is kind of a simple exercise. This compound interest, when you do it over and over again, that amount of money, this is how really everything works in the banking world. When you get a credit card, when you get a student loan, when you buy a house, they take interest on the stuff you already owe as well. And they keep taking interest on that. I explain it more in class. This is just kind of the walkthrough. But what we talk about in class is this. Instead of me doing 12.5% this amount and then adding it back on, what I can really just do is find 100% plus 12.5%, which is 112.5%, which is 1.125. If I multiply 13,900 times 1.125, I get that 15,637.5. So if I want to do this for 5 years, the shortcut is take the money we owe, 13,900, and multiply by 1.125 5 times. It's a lot faster than what the book does. They make you keep let me get this out of the way here. They make you keep finding the interest and then adding it back on. Find the interest, add it back on. Well, if you just find 112.5% one time, you don't have to add it back on. And then we have to do it for 5 years like they want us to on this problem, because it says for 5 years. Okay, I'll just do this times this 5 times. So 13,900 times 1.125 once times 1.125 twice times 1.125 3 times, 4 times, 5 times. And by the end of all of that, that's a fair amount of money then, total. 25,048. 0.25, so just in some change. Again, it isn't perfect. They're like when you buy a house or you buy a car, you're paying it off partway through, so you're not spending all of this money all the time. But realistically, this is pretty close to what happens if you buy a car or a house. It's not quite as expensive as this. It's a little cheaper, but you tend to pay actually quite a bit of money, more than what the actual price is when you do your loan, because you're paying a little bit off each month at a time. And what it does, it keeps going back and finding interest on the previous amount. So it wouldn't be $25,000, but it would definitely not just be the simple 12.5% times 5 years that we did earlier in the chapter, or earlier in the section. Okay, all right. So I'm going to do one more problem. I know this is a long video, but this is a longer section. One more problem, number 23. Toya has a car loan of $8,500. Over the course of the loan, she paid a total of $5,525 in interest at a rate of 13%. How many months was her car loan? Now, the thing they don't tell us is we have to assume this is simple interest. Even though, again, in real life it wouldn't be, we have to assume simple interest. If we don't, we can't do this problem yet. We don't. In Algebra 2, you'll learn how to, but not algebra, not a pre-algebra. So if simple interest is this, so here's what we know. We know the interest. I know interest was $5,525. I know the interest rate was 13%. And I know the initial cost was $8,500. So when I go to that interest equals PRT, I know the initial amount principal. I know how much interest was earned. And I know the rate. What I don't know is I don't know the time. So plug all that in. Interest is $55.25. Principal is $8,500. Rate is 0.13 because again it's 13%, but as a decimal, and then times time. And then we just get out our calculator and do 8,500 times 0.13. That gives us 1,105 T. This is 5525. And divide 5525 by 1105. Okay. And we get 5. Now here's the problem. This is again in years. They wanted to know months. So they're being little, they didn't need to do that. We got 5 years perfectly, but there are 12 months in a year. That gives us 60 months. Okay, so that's how long it would take us. Okay, great.